All right, hey students, it's Mr. Chang. We got to talk about 7.2 compound interest today. All right, we're talking about what something is going to be worth in its future value and its present value. And compound interest is different from simple interest because it's not a linear growth. It doesn't grow by the same amount, that's the interest, every time we calculate interest. In compound interest, every time you calculate interest, you calculate the interest off of the original amount, that principal, plus any interest that it's already gained. So as the interest keeps on going, because the days keep on going, or weeks or months or whatever you're counting by keep on going, then the interest piles on to the principal and it gets bigger. And so we calculate interest off of the principal with the interest together. And when you do that, you actually end up with an exponential growth situation. Okay, so when we covered exponential growth, we covered exponential growth situations like those word problems, and this is essentially what we're talking about here. Okay, so those of you guys who get that will should be able to pick up on this lesson pretty smoothly. Let's go. Our goal is to calculate the future value of an investment or loan with compound interest. Okay. And our goal number 2 is to calculate the present value of an investment or loan with compound interest. So both of them we're going to look at. Compound interest is interest calculated on the principal and accumulated interest, like I said. And the formula for calculating compound interest here, FV is equal to PV times 1 plus I to the exponent n. This formula is made up of these different variables. FV is actually one variable, okay? It stands for future value. So when you think FV, I want you to think about what is that amount of money that you put in eventually going to be worth, and that is the future value. Okay, is the total value the investment or loan will be worth. PV is the principal or the initial amount. Initial means time is 0. That's when you start off with. How much money did you put in to start it with? I is the interest rate divided by the number of compounds per year, and also make sure you divide that interest rate into by 100, right? Because you got to take that percentage to turn it to a decimal. Then you got to divide it by the number of compounds per year. Then we're going to find n, which is the total amount of compounds that are going to happen. Okay, and the total amount of compounds is made up of two things: the compounds per year multiplied by the total number of years. All right, so the two formulas I just talked about for interest rate, okay, interest rate is equal to the rate divided by the compounds per year is right here, okay, and the n value is the compounds per year times the number of years that you go by, which is right here. Okay, those are both of those calculations. So what about compounds per year? Let's take a moment and let's talk about that. C/Y, compounds per year. That's how many times that compound is going to happen. So in a word problem, I'm not going to tell you that it's once a year, twice a year, 4 times a year. It gets a little bit more encoded because I'm going to use a word like annually. Okay, like think about anniversary. It happens once a year. Your parents' anniversary is once a year. The Raptors' 25th anniversary was last year because the team started in 1990. 1995. My bad. 1995. It's been 25 years since, right? And then that's annually. Semi-annually is when you celebrate something twice a year, right? Semi actually means half, so you want to take a year, divide it in half, so there's 2 times. So some couples who really like celebrating things or just want an excuse to do so will celebrate their semi-anniversary, which is 6 months from the date that they started dating. Quarterly is when you take a year and split it into 4. That means 3 months at a time, because every 3 months, January, February, March, is 1 quarter. April, May, June, that's the next quarter. July, August, September is the 3rd quarter, and the 4th quarter is September, October, November, December. Okay, so that's what quarterly is. If you want an example, businesses file quarterly reports where they release their financial information to their stockholders, people who are invested into the business, so they can see as investors whether that business is doing well. If it is, then you put more money into it. If it's not, then maybe you take money out or get people fired. Then you go monthly. Okay, monthly is 12 times a year, and daily, which is 365 times a year. There's nothing really that I'm missing except for weekly. And if we want to talk about weekly, that is 52 times a year. How do you know that? Because you can think about how many days are in a week. 7. And how many days are in a year? 365. Well, if you're ever lost and you're like, well, I don't know how many weeks are in a year, take 365 days divided by 7 days in a year. And you get 52. 52.14 actually. There's a little bit more than 52 weeks in a year. All right, so that's how you do it. Remember to use these 2 checkmarked formulas when you're calculating I and N. And I'm going to tell you the main formulas we need to be able to work through this entire section. We've got the future value formula right here for you. Future value formula is FV is equal to PV times 1 plus I to the exponent n. That is the compound interest formula. Okay, you could rearrange it. If I was to isolate PV to calculate the present value, all I'd have to do is to multiply both sides by the inverse of 1 plus I to the exponent n, which would be 1 plus I to the exponent negative n. And if you do that, then the PV will be by itself, and it'd be FV times 1 plus I to the exponent n. And you can see that right here. Okay, so really, these 2 formulas are like the same thing. Okay, but depends really what the question is asking you to find. If it's asking you, hey, how much is something going to be worth in the future? You're using the future value formula. If it's saying how much is it's worth this much in the future, but how much is it worth now, or how much do you need now to be able to have that much in the future? That's the present value formula. Okay, we're just going to bounce between these 2, and that's it. Example 1. $1,000 is invested at 5% per year, compounded semi-annually for 3 years. How much will it be worth? How much will it be worth? So look at that, right? You got $1,000 is invested at 5% per year, compounded semi-annually, okay? For 3 years, how much will it be worth? So there's some key things I want to bring about here. The first thing is when you see the word compounded, this means you're going to be using one of these 2 compound interest formulas, okay? It has to be compound interest, okay? Compound interest, because you see the word compounded, that's already telling you it's going to be a compound interest formula. The biggest mistake you can do right here is to go, oh, this is I-party. No, that's simple interest stuff. Don't do that, okay? Simple interest occurs when you have a word problem that simply does not use the word compounded, okay? Or it'll even state simple interest, okay? So in this case, this is compounded interest. So compound interest, it could be either the FV or the PV formula. So let's figure out which one. How much will it be worth? Will is a great example to tell you we're talking about future value, okay? What is the future value? So we have a bunch of details here. We're trying to figure out FV, how much will it be worth? So that's this one right here. And let's write out the formula. FV is equal to PV times 1 plus I to the exponent n. Okay, all we're going to do is substitute in and solve. Let's just make sure we have everything we need. PV is equal to what you start with, which is $1,000. Okay, it's invested. That's I now. Let's talk about I. Now, remember, we have a formula for I. I is equal to R divided by CY. Okay, R, which is your rate, divided by your compounds per year. Okay, let's try to work on that. What's the rate? Well, the rate is 5% per year, right? And it's divided by your compounds per year. How many compounds per year? It says compounded semi-annually, which is, semi-annually is twice a year. 2 goes on the bottom. Okay, now let's just turn the 5% to a decimal, so that turns into 0.05 divided by 2, which should give us 0.025. That is our interest rate that we are charging every semi-annual compound. Okay, if you charge 0.025 6 months in and charge 0.025 another 6 months in, then for the year you would have charged 0.05 or 5%. So we got I. What else do we need? We need N. So let's talk about N. Here's some space. N is equal to the total number of compounds. Well, what's the compounds per year? The compounds per year is, well, let's write out the formula. CY times the total number of years, right? So N is equal to 2 compounds per year times how many years? We're going for 3 years, right here, 3. N is equal to 6. There will be a total of 6 semi-annual compounds before this investment is over, okay? Before the time is over. So how much will it be worth after these 6 compounds, or simply 3 years? Let's plug it in. FV is equal to 1,000 times 1 plus I, which is 0.025, to the exponent n, positive n, and positive n is 6. Write that better. Okay. And I'm just going to pause it and show you the answer. Yeah, so there you go, right? It's going to be worth $1,159.69. But how did you get that, right? Make sure you follow BEDMAS. A lot of you guys will be tempted to multiply the 1,000 directly into 1.025, but you can't because 1.025 is the base belonging to the exponent 6. You have to do the exponent first. Let's go 1.025 to the exponent 6 equals, and then you times it to 1,000. If you have a scientific calculator that allows you to do it, you can actually try punching it all at the same time, 1,000 bracket 1.025 or 1 plus 0.025 in the brackets to the exponent 6 and see if it'll give you 1,159.69. I mean, if your calculator does it for you, then that's great, right? Because it'll sort out BEDMAS. But if it won't, then you're going to have to sort out BEDMAS first, okay? Make sure you do the brackets, the exponents, and then multiply by 1,000 at the end. All right. One more little follow-up to it is how much interest was earned on the investment. Did it earn $1,159.69? No, it's worth $1,159.69, but it started off being worth only 1,000. Right? So I think you guys can do the math, but what's the formula? A, remember this one, A is equal to the principal plus the interest. Okay? When it comes to compound interest, however, we can rewrite this as future value is equal to the present value plus the interest. And when I'm asking you how much interest actually occurred, I'm actually asking you for the interest. What is capital letter I? Capital letter I is not a decimal or a rate. It is the actual amount of interest that happened. Okay, so let's isolate it. Let's send that PV to the other side, and let's work it out. So we're going to say I is equal to FV subtract PV. I is equal to the FV of $1,159.69, subtract the PV of 1,000, and you're going to get I is equal to $159.69. Therefore, it earned $159.69 interest. Got it? Got it? Good. Okay, let's move on. So we just talked about future value, right? So here are a couple of future value questions, but we're going to do just number 3, okay? And let me set it up, and I'll have you carry it away. $3,000 is invested at 4.54% per year, compounded monthly for 5 years. How much will it be worth, okay? So let's break it down. $3,000 is invested at 4.45% per year, compounded monthly for 5 years. How much will it be worth? Let's come in with a breakdown. Okay, we got $3,000 invested. That is your PV. How much will it be worth? We're talking about FV, right? 4.54%. That is your R, right? How many compounds per year? We are talking about CY right here. And we are going for 5 years. Did I say 5 months? I meant 5 years. 5 years. So this is your years. All right. So try to think about what happens here. I'm going to pause it and reveal the answer. All right. Let's take a baby step here. Did you get these answers? Okay, you should have came up with saying that the present value is 3,000. You're going to plug in your rate, which is 4.54, but you might as well just divide it by 100 in one shot. So 0.0454 divided by 12, right? And you get 0.03783. And then to get n, you get compounds per year, which is 12, times the total amount of years, which is 5. So you get 60 total compounds. All right, you're going to plug it into the formula, and bam, did you get this? All right, here we go. 3,762.80. It's going to be worth 3,762.80. All right, $3,762.80. I could ask you, how much interest did it actually make? You're going to say I is equal to FV subtract PV. Plug it in. FV is 3,762.80. PV is 3,000. You get 762.8, right? You can do that too. All right, so what if I was to throw a little bit more of some challenge to you? We've been trying to do future value calculations, but have a look at this. It says $400 is required in 2 years. The money can be invested at 6% per year, compounded monthly. Calculate how much money you need to invest today. That's the big one. This screams out present value. Okay, what do you have today? So let's make sure we got everything else we need. In 2 years, the money can be invested at 6% per year, compounded monthly. Calculate how much money you need to invest today. So we need the present value formula, okay? And we could start by writing that out, and we also got to label everything we have. So PV is equal to, okay, future value times 1 plus I to the exponent negative n. Okay, that is what your present value calculation is going to look like. PV. Make sure you calculate PV. Some of you guys are going to fall into the pitfall and miss out on that little detail. It says invest today, and they're going to be like, oh, this is a future value calculation. You're going to get killed on that. All right. You do a future value calculation for a present value question. Well, you did compound interest, but you did it for the wrong formula, and you didn't know the difference, to be honest. So maybe you'll get like a 3 out of 5. Okay. All right, let's try this. What do we have? Future value. $500 is required in 2 years. That means you don't have it right now. That's $500. That's money in the future. You got 2 years. 2 years. That's a total amount of years. We're going to use that. But what else do we need? In the formula, we got I, right? I is equal to your rate divided by your compounds per year. Let's see if we can make this a little bit smoother. Our rate is 0.06, not 0.6, everybody, right? 0.06, and we've got to divide this by compounds per year, which is 12. And this turns into a clean 0.005. All right, and then we also need the n value, which we're going to plug in as a negative, right? But n, let's see if I can fit it here, n is equal to your compounds per year times the number of years you want to go for. In this case, we are compounding 12 times a year, and we are going to go for 2 years. 24 total compounds are going to happen. Okay, take all these values, plug it in. It should look like this. PV is equal to 500 bracket 1 plus 0.005 to the exponent negative 24. Okay, you have a future amount. You want to figure out what you had in the present. You're going backwards in time. You could think that should be negative, all right? Okay, so I'll pause it and let's see the answer. All right, look at that, $443.59. There's a lot of problems. There's a lot of things I want you guys to get clarified about. First off, when you punch this in on your calculator, make sure you use the negative button on your calculator, okay? on my Casio, that is on the top left, 2 buttons above the 7 in a bracket, all right? Hit that negative button. Don't hit subtract. For some of your calculators, you try using the subtract button, and then 24, that's going to put it in an operator, and it will change the way the calculator interprets this. Okay, so make sure you use the negative button. So PV is equal to $443.59. Does that make sense? Yes, it is less than what you started with, right? Because what you started with is what you have in the future. You have $500 in the future. You want to invest some money now so that you can have that $500 in the future. There's no way you're going to invest $600 now so that you can have $500 in the future. You want to invest less money, okay? In this case, you invest $443.59. Okay, give it 2 years. You can plug this in as a present value and calculate the rest of this and figure out that the future value will actually be 500. All right, 443.59. Therefore, today. All right. We got a couple more. Anne-Marie wants to repay a $2,500 loan in 1 year. She has found an investment that has an annual interest rate of 6% compounded monthly. 6% compounded monthly. And how much should she invest today to reach her goal? And now 6% compounded monthly, unfortunately, that's too similar to what we just talked about there. I'm going to make a little bit of a modification because that's 6% compounded monthly as well. Actually, let's try to use something a little bit more common to what we have now. And let's change this to, everybody do this with me. Let's change that 6% to a, let's use 3%. Okay, let's change that to 3%. She's got an interest rate of 3%, and let's compound this. Let's compound this weekly. That sounds interesting. How much should she invest today to reach her goal? Okay, today. So look for that. What type of value we're looking for? Present value. Okay. You see all the details there? Can you guys figure out how much Anne-Marie is going to need today to reach her goal? Okay, so start off by writing out the details down the side. Start with a formula. Okay. Which formula should you use? Look at the variables of the formula. Write them down underneath, just like we've been following. And if you have them all, you can plug them in and work it out. Okay. I'll pause it. Let's see if we get the same thing. Check in. Did you get this? 2500, 0.000577, and the end value calculates out to be 52. You got these? Then there you go. Anne-Marie needs $2,026.13. And again, if your calculator allows you to punch it all in one shot, go ahead and do that because you're obviously getting the same answer as me. And Anne-Marie needs $2,426.13 today. So that after exactly 1 year, she's going to have $2,500. Okay, it'll accumulate interest upon interest and be worth $2,500 within a year. Great. You know, you made what? $73.87 interest off of a year. That's actually pretty good for nowadays. All right, that's a shout out to Anne-Marie. Here we go. Number 6. If you earned $1,078.77 in interest on a $5,000 investment over 900 days, compounded monthly, what was the annual interest rate? Okay. Do you guys see that this is a bit of a challenge? Okay, so take out some paper, give it a shot. Okay, try to figure out what happens here. If you earned $1,078 in interest on a $5,000 investment, okay, that means you put in the $5,000, you earn $1,078.77 interest. And the investment lasts for 900 days. but it's compounded monthly, what was the annual interest rate? The 900 days is your total amount of time, but the total amount of time needs to be multiplied by your compounds per year for something like n. So how do we turn 900 days to the total amount of years? Okay, there's a bit of stuff that happens here. Let's see what you guys can do. I'm going to let you have this challenge and figure out the interest rate as a percentage, please. Okay, I'm going to reveal the answer after my countdown from 3 to 0. So I want you to, during my countdown, pause the screen and try it yourself. 3, 2, 1. All right, so did you get these values? Were you able to figure out that the future value was $6,078.77? I mean, I just wrote down the future value formula just because it uses a positive n, but I won't be really using this formula per se, or the present value one. I got to manipulate it because I'm trying to figure out the interest rate, R. Okay, we're a little bit far removed from that. But at least just having the formula allows me to figure out what are the different pieces I need. And, you know, I need FV, $6,078.77, PV. I can't really get too far because I don't have everything there, but I am going to use R. I'm going to rearrange that to figure out R because that's what the question wants. What is the interest rate? Not the interest rate per compounding period, but what is that rate entirely? And then it also wants to know N, which is compounds per year times year, and years, 12 compounds per year because it's monthly, times, the years. I have to convert that to years, right? Because it's in days. So 900 days divided by 365 days per year gives me 2.466 roughly, which is 29.6 total compounds. Okay, so that takes me up until getting all the variables. At this point, I got all the variables, but I'm going to isolate I. So the next step here, which I'll be doing in red, will involve me isolating I. Okay, so I'm just going to take the formula first and do it maybe. And you'll see that I originally had FV is equal to PV times 1 plus I to the exponent n. So, you know, that's multiplying here. I'm going to get rid of that first before I handle the exponents, right? Because remember, you want to go reverse BEDMAS when you're isolating a variable. So the first thing I'm going to write here is FV divided by PV is equal to now 1 plus I, weird head, to the exponent n. All right, so I got this far. But how do I get rid of the exponent n? What do I have to raise both sides by so that I can have exponent 1 on the right side? Because I'm trying to get that I by itself. In order to do that, I need to use the power of a power rule where I figure out what I need n to be multiplied by so that it can actually work out. So what happens here is this will be FV over PV in brackets. And if you guessed it, this will be 1 plus I now, because I multiply both sides by 1 raised to the power of 1 over n, right? And this will be 1 over n. And if I raise both sides to 1 over n, this is what it looks like now. I've got this, right? Because if you multiply n times 1 over n, that'll become 1, which allows me to just open the bracket. Next step here is I got to isolate the I by subtracting 1 from both sides. So I'll get to this point. FV over PV, well, to the exponent 1 over n subtract 1 is equal to I. Okay? Or you can write it the other way and just put the I on the other side. I is equal to this. So let's figure out what this actually works out to be. Okay, let's get you guys to sub in our values. And all right, did you get this far? 0.00662 197968, all that stuff is a part of it. But that's I'm trying to get R. Okay, so let's plug it back into the formula over here, and let's get R right there. Okay, we got to use this formula. R is equal to I times your CY, right? So I'm going to pause it, and let's see if you get it just the same as me. So maybe I'll use brown here. R is equal to I times your compounds per year. And 3, 2, 1. All right, so I got this. That's a rate. Anybody know what I got to do? Yep. The rate right now is a decimal. Remember, we got to switch it back to a percent. So we got to times it by 100. That'll turn to R is equal to 7.95%. Okay. Boom. Therefore, the rate is 7.95%. All right, there were a lot of little tricky steps to be careful about here. This is definitely a challenge for those of you guys who are up for it. If you got it, give yourself a big pat on the back and a big air high five from me because you deserve it. It was not easy, and the practice is right there. Okay, I want you guys to try these questions. Let me use a proper color. It is 95 to 96, 3, 4, 6 to 8. That will be future value, and then 98 to 99, 2, 3, 5, 6 will be present value. So that'll give you a good look at both situations. And there's your practice. Check your answers, make sure you're getting it. Anything you're not sure about and you want some answers for, take a picture of it, send it to me, including your work. Send it to me by email, and I'll get back to you about either where you messed up or like an entire lesson if that's how lost you are. Okay? All right, that's that. Hope you guys are great, and take care. Bye.